Assalamualaikum. Today we will present our infrastructure design project, which is a comprehensive structural and infrastructural project. This is our team member for this project, and first one is Muhammad Zahimi bin Muhammad Nasir. The second one is Wan Ishraf Asri bin Wan Rosli. The third one is Wan Nosharin bin Wan Azman. The last one is Muhammad Akeh Nu'man bin Roslan. And this is our table of content for this project. The first one is introduction, and the second one is project briefing and structural design, earthwork, road and drainage, sewerage, water supply, project costing, and lastly is project scheduling. For the introduction, our project title is Cadangan Membina 167 unit rumah teres 2 tingkat di atas lot 703, lot 31548, lot 31549 dan lot 729. For the project background, Axis Empire mission is to achieve the highest possible standard of quality and service in the building and construction business to provide its customer with the utmost level of satisfaction. For the project briefing, our project location is in District Batu Pahat. And our location for project is Mukim Simpan Kanan, Daerah Batu Pahat. The local authority for this project is MBPB Johor.
Now we proceed to structural design. For the structure design, we use two Eurocode books, which are Eurocode 1 and Eurocode 2. Design of concrete structure is the primary design code for designing structure components such as slab, beams, columns, and foundation under the ultimate limit state. Why we use Eurocode? It is because for the Eurocode 1, it gives design guidance and action for the structure design of buildings and civil engineering work, including densities of construction material and store material, safe rate of construction element, and imposed load for building. While Eurocode 2 applies to the design of buildings and other civil engineering works in plain, reinforced, and prestressed concrete. It has been established that the Eurocode is a trustworthy source for current and technically accurate recommendation for concrete design, and that is an ideal fit for national annex. For our project, we have to design 167 units of two-story terrace house. For the design specification, we use FCK 30 Newton per millimeter square. FYK we use 500 Newton per millimeter square, and design life is 50 years. Exposure class is XC3, and last fire resistant is R60. This value we obtain from the appendix and also Eurocode 1 and Eurocode 2. So this is architectural layout plan. On the first floor, we have three bedroom and one of them is master bedroom. We have two bathroom, family hall, and two balcony. On the ground floor, we have one bedroom, one bathroom, and also kitchen and living room. On the roof floor, we have nothing. So this is structure layout plan. In one plan, we have three house. This is our building structure that we use in Esteem software.
This is the comparison that I get from Esteem and Manual for Slate Design. Okay, for Esteem, for Sinum is 25 and for Manual is 35. For AS provided, for Esteem is 2H16 and Manual, I also get 2H16. And for transverse reinforcement is for bottom bar, and for esteem is 2H16, and for manual I get 2H16. Okay, for detailing, the top and bottom. For the top is T10, and for spacing 250 spacing, and for bottom is also same T10 and 250 spacing.
For the continuous beam, we design beam on the first floor and the number beam is 28. So this is comparison between the manual calculation and esteem software. For the CNOM, for manual calculation, we use 35 millimeter and esteem we use 25 millimeter. So the difference is around 10 millimeter. Beam size is same. For the manual, we have 100 times 500, and for the esteem is 100 and time 500. It's provided for the manual calculation. We got for H16, and for the esteem we got 2H16. So the difference is different around two number of bar. This is detailing for the continuous beam, and this is detailing for the continuous beam.
Okay, for the column design, for nominal cover for manual 40 mm, and then we got from esteem 25 mm. And then for the column size, we propose the size 300 mm times 450 mm, and then we got the esteem 300 times 300 mm. Then as provided, we calculate and we got 6H32, which is 4,830 millimeters square, and for the esteem 10H10. And then for the shear link, we calculate and got H10 3 300 center to center, and then for the esteem H6 1000. Okay, this is the column detailing. For the first picture is one floor to ground floor, and then ground floor to stump.
And this is our pad footing design. So in this design, we will compare with esteem and manual. So the CNOM for manual that we use is 35 mm, while the esteem is 50 mm. So the difference is 15 mm. And the foundation size for the manual is 1600 times 100 1600 and times 250. For the esteem design is 800 times 600 times 300. And the AS provided for the manual calculation is 4H32, while the esteem is 5H10. The bearing capacity for the manuals and the esteem is same, which is 110 kilonewton per millimeter square. So this is our detailing for pad footing. The first one is for plan, and the second one is from the YY, and the third one is XX axis.
Earthwork is one of the important process in the construction works. Is the process where it includes soil excavation, transporting, and place the soil in a location. Excavation, hauling, spreading, compacting, and finishing are the five major processes that must be completed for productive earthwork, and each procedure requires the selection of appropriate equipment. This is our layout for cut and fill that, and we use grid method to calculate cut and fill for our site. Cutting and filling is the process of shifting soil from one location to another in order to level the land. A cut occurs when earth is taken from above the intended ground floor, whereas a fill occurs when earth is utilized to fill an empty portion up to the needed ground level. Cutting and filling is a standard method for creating an equal ground surface. In our construction, the cumulative amount of total cut is around 68,000 meter cube, and the cumulative amount of total fill is around 14,000 meter cube. The amount of total cut is more than the fill, as many ground level of the construction site is higher than the surrounding ground level. The total cost for earthwork is around 1.142 million ringgit.
Okay, we move to the road and drainage design. So for the road and drainage design, we design in compliance Jabatan Kerja Raya JKR. So there are a few guidelines that has been used for the road design, such as manual on traffic control device, standard traffic applications. The second one is manual on traffic control device, standard traffic signs. And then we use the CAD sign design and application. And then California bearing ratio CBR report test. Okay, for the road design, we assume the percentage traffic volume, or we known as PCV, 16%, no detailed breakdown by vehicle type. Then we assume the lane distribution factor 0.9, which is two lane in one direction. And then we assume the train factor 1.0 because that area is a flat area. And then we assume the design life 20 years. And then the annual traffic growth 4%, which is commonly used for the group. Okay, next. Okay, this is the our road layout. So as you can see, the arrow is the two-way direction for each row houses, and then propose the stop apa? We propose the stop signage at the intersection road, and then we propose the speed limit signage, which is 30, which is 30 kilometer per hour at the residential area. Okay, as you can see here, so this is the calculation of pavement design. So for the average daily traffic, we assume the 150, and then we assume the L 0.9. As I said just now, two lane in one direction, and then T 1.0 type of train flat, and then the value LEF 3.7, and then we calculate the design traffic SESALYSL base year, and then for the traffic we assume 20 years, and then for the final result we got the subgrade strength SG2, which is the CBR strength to 12 to 20. Okay, so this is the result or summary for the pavement structure. Uh, so we design as SG2T1, which is CBR 12.1 to 20%, and then for the surface cost, B2 meaning surface cost 50 mm, and then crush aggregate base 200 mm, and then granular sub base 150 mm. Okay, we move to the drainage designs. For the drainage design, we compliance in guidelines Jabatan Kerja Raya Malaysia, and then Urban Stormwater Management Manual for Malaysia, or we known as MASMA, and then Department of Irrigation and Drainage Malaysia, or SPAN. Okay, so this is our drainage layout. We propose the drainage layout based on the uh, blue 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 color, as you can see here. This is node 1 and node 2, and then this one node 3. So we propose the drainage layout based on the ground level. So 1 to 2, 2 to 3, and then 4 to 1, the water flow. Okay, so this one for the drainage calculation for design. So as you can see here, so our development is link house. So this one for the find the IDF empirical equation, and then we find the subcatchment, and then we find the T naught O over lane flow time. We got the 20.83 mm, and then we propose the rectangular drain with gradient 1 ratio 200, and then we find the TD, which is the 5.18 mm, and then we find the velocity in rain, which is we got 1.23, which is over than over than which is included in range, which is uh, over than 0.6 meter per second, and then lower than 2 meter per second. This is for the rectangular and rectangular and open drain limit. Okay, and then we find the peak flow capacity, which is we got the 0.445 meter cube per second, and then we find the rainfall intensity, which is we got 139.34 millimeter per hour, and then uh, and then we find the peak flow from the rainfall intensity we calculate just now, and we got the 0.006 meter cube per seconds, which is lower than Q capacity. Just now I said 0.445 meter cube per second, which is mean okay. Okay, this is the result. We calculate using the Excel based on the drainage layout. So this is the summary of drainage design. So development area, rumah teras bertingkat, state Johor, and then nearest station, sector JPS Batu Pahat. And then we got the IDF real equation from the nearest station. And then we propose the rectangular drain. For the size is 0.3 times 0.50. And then for the drain velocity, which is we calculate, and we got 1.23 meter per second, which is in range 0.6 meter per second, and then lower than 2 meter per second. That's mean okay. And then we calculate the capacity discharge, and we got the 0.445 meter cube per seconds. And then for the rainfall intensity that area, we got the 139.34 millimeter per hour. And then we calculate the peak discharge, and we got the 0.006 meter cube per seconds is lower than Q discharge, which is 0.445 meter cube per seconds. That's mean okay. That's mean Q capacity is larger than uh, Q discharge. So this is the proposed roadside drain, rectangular drain. Okay, next we move to the design the detention point. So for the guideline, we follow the Urban Stormwater Management Manual for Malaysia, or we known as MASMA. So the objective of design detention point is to reduce the peak rate of runoff to stream or storm sewer. And then the next one is to prevent localized flooding. And then to improve water quality by filtering out pollutants, and then to reduce the stream bank erosions, and then to provide habitat for wildlife. Okay, so this is our calculations of design detention points. And so the proposed area 5.219 hectare, and then we got the IDF imperial equation based on nearest station, and then we find the overland flow T naught, and then we calculate the drain flow TD, and then we calculate the pre-development and post-development. And then for the 5 years ARI, we got the 0.309 meter cube per seconds. And then for the 50 years ARI, we got the 0.6615 meter cube per seconds. And then we calculate the maximum storage for all two hydro. And then we calculate the sizings of outlet pipe, and then we provide the number of pipe egg, and then the diameter 300 millimeter, and we got the Q actual 0.708 meter cube per seconds. That's mean okay. And then we calculate the sizing of spillway, and then we got the Q required, which is negative 0.094 meter cube per seconds. And then we find the Q spillway, and then we got the 1.032 meter cube per seconds is larger than Q required, negative 0.094 meter cube per seconds. That's mean okay.
For the sewerage part, first one is sewerage guideline, and guideline that we follow is Suruhanjaya Perkhidmatan Air Negara and MS 1228 1991, which is code of practice for developer on the design of installation of sewerage design system. And this is our sewerage layout plan, and in this layout plan we'll show um, flow of manhole and the sewerage layout until the water storage. And next, this is design specification. Design according to the amount of sewage discharge per person, and the material is vitrified clay pipe (VCP). The diameter of pipe is 225 mm. The gradient is 1:100. And this is our design parameter. Depth of manhole. minimum depth of manhole is 1.2 meter, and the maximum velocity is 0.8 and 4 millimeters square. The bedrock manhole and the design equation, which is we use a Manin equation. For the sewerage calculation, we'll find the population equivalent, which is PE. So first one, we will have two-story house, 167 two-story house, rate 5 per house, and PE 835. And the second one is surau. The count for surau is 835 and the rate is 0.2 per person and the PE is 167. Next is our sewerage calculation. In this calculation, we check the velocity check and full pipe flow. We also will find the manhole and level computation. Lastly is sewerage summary calculation. That's all for me. Thank you.
Okay, today I want to present about water reticulation and or water supply design. Okay, for the title is cadangan membina 167 unit rumah teres dua tingkat di atas lot 703, lot 31548, lot 31549 dan lot 729. Mungkin simpan kanan daerah Batu Pahat Johor. Okay, for the purpose of the report, ensure that the fed load can receive an adequate amount of water from the system based on its layout, pipe size and pump capacity. Second, be designed to ensure that water is available across the whole fed load even during times of high demand. Next, ensure that the kettle have access to drinking water that is fresh, cool, clean, and good quality. Okay, for I use from for this design for water reticulation is first JKR design. The second for fire flow requirement from JKR standard, and the last one is from SPAN. And design method I use in this calculation is William method. Okay, this is I got from a span. And for this table, for first table, okay, this is I got from a
for
span
double
and terrace house and the average daily water demand is
I got from a span
1,500 per
and
unit. And for
this
for
is
most
I
queue
got from a
or
span
other place of
and
worksheet is 50 per person.
this is
And the
I
second
got
table
from a
is
span and
I got
this is
from
I
span,
got from a
also from
span
span, and this is the
and
table that I use
this is
compile
I got from a
the
span
pipe
and
number from node to another node,
this is
the length,
I got from a span
diameter,
and
HWC, HL, and also the velocity.
this is
This is I
I
got
got
from the
from a
span.
span and
Okay, for this figure is the appendix from the span. Okay, I got for head loss. I got my head loss and is more than 0.002. So I refer at this. And for the next table, I use for take the type of pipe. And I use HDPE for residential area. Okay, this is the formula of the Hazen William formula. HF Q D. The pipe diameter I got from the HDPE. The diameter is for 1 to 5 millimeter, HDPE diameter, and the length I got from the drawing. And C, friction coefficient I got from the span, also from span. And the type of pipe, C coefficient, that next table show HDPE. Hazen-Williams coefficient, so the value is 120 for friction coefficient. Okay, for the first table, for the first picture, show that water demand calculation for the residential house, 1,500 liter per day, and times by the number of house unit. And for surau or mosque, I get 50 liter per day, and also from span. And the reserve dimension is 9 times 9 times 2 for proposed tank size. And for elevated water tank, rectangular shape, is proposed size is 11 meter times 10 meter times 3 meter height. Okay, for the next figure, hydraulic calculation. From this is the example of calculation uh, for calculate to find head loss HF. Okay, the length of the pipe is 37.87. Diameter of pipe 1 to 5 meter. I got from the span. Type of pipe HDPE, and also got from the span. Coefficient 120 from the span. MPL at note 2 is 15.60. And the velocity that I calculate is 0.36. 0.36, so it's considered pass. And for head loss, this is the formula for head loss, and also the Q diameter, length, and coefficient, and also have. So I just put in this tab in this formula and calculate the head loss. For head loss, I get 0.066. So it's considered pass. For residual head is 25.73. It's more than 7. In appendix span, if the residual head is more than 7, so it's considered pass. This is table of flow computation, and I created this table. The table show from note 1 to note 21, and the length I get from the drawing, and diameter is also same because I use HDPE pipe. And for HF, I use a Hazen-Williams equation to get HF. And all the head loss, I consider pass because I refer from span, and also velocity is considered pass. Okay, for the layout, water supply is first figure that I get from EPANET, and I apply to my drawing, my side drawing, and this is the design flow that for use for houses. Okay, for the summary, for water reticulation, first a demand calculation, I get demand calculation. The second one is using Hardy-Cross method, or using Hazen-Williams equation to get HF. Okay, why I use William equation? Because it widely used in industry application instead of Darcy Weisbach equation. And the second one, why I use William, because exponent adjusted the roughness coefficient is more or less constant over a wide range of parameters. And the last one is flow layout water get from Ethernet, and I apply to site drawing. And that's all from me. Thank you.
Okay, we move to the project costing for the structure and infrastructure. So this is the summary total cost of estimation from the bill of quantities. So the for the total structural work is around 16 million, and then for the earthwork 1 million, and then for the drainage around 130,000, and then for the sewerage system is around 311,000, and then for the water reticulation around 160,000. Then for the sewerage system is 2 million. So we estimate the total cost is around 19 million, almost 20 million.
And this is Gantt chart. Okay, for project scheduling, I calculate that 540 days for construction, pre and post.